Okay, just want to do a little breakdown on quadratic equations. So we'll say right here x equals 2. So here 2 units. So basically it's 1 and 1. But x equals 2, and then this is x plus 4. So this would be 2, right? This would be x, and then plus 4, 1, 2, 3, 4. It gives us a total of 12. So if we look at the equation here, if we express it in this manner, x squared plus 4x equals 12. So in an equation, a lot of times we'll see x squared plus 4x minus 12 equals 0. They call this a constant, but the constant is actually the total. So if we take x squared right here, that's just this portion here, so these 4 units, and then this represents the plus 4. So we have x squared, and then if we take this area, x times 4, we have x squared and 4x minus the total gives us 0. So, and if we express it in this manner, we have x squared and then 4x, we just distribute, and that's what we end up with. Kind of simple. Now if we break this down, one of the ways to break this down is to ask what two numbers added together will give us 4 and multiplied together would give us negative 12. So the answer to that, x plus 6 and then x minus 2, or x plus negative 2, but either way. And if you think about what you're looking at here, there's really, it's dissimilar here in a sense. So x minus 2, and if you add this, it's not going to work out the same. So if we just take that one step further, and we say that x equals 1. So this is 1 plus 5, and this would be 1 plus 1. So now we have x plus 1 times x plus 5 equals 12. So if we just distribute everything, we end up with x squared plus 5x plus 1x plus 5 equals 12. So here we're adding x's, but we got a 5 here. So we just combine all our like terms, subtract 0, just kind of, and then we abbreviate that a little bit. X squared plus 6x minus 7 equals 0. So again we have x plus 7, so we had this added up to 8 here. And if we look in our previous, this added up to 8. And here we have x minus 1. And here we have x minus 2. But we have a value of 2 here, as that we're expressing with x, and here we have a value of 1. So if we take x minus 1, this resolves to 0, and so does this. So if we take this equation here, or we take this formula, and we say x plus 2 times x plus 5 gives us 18. So I'm just adding one bunch here. So we got 6, 12, 18. So we have x squared plus 5x plus 2x plus 10 equals 18. So who knows what happened? Maybe they just got tired of expressing x's at the end and said x squared plus 5x plus 2x, okay, I've had enough, and then there's 10 more, which makes 18. So if you just we break this down into like terms, so we have 5x, we have 2x, and then we got 10 more. And we have x squared. So if we combine that all together, we have the same scenario. Now in this case, we have 9, x minus 1 cancels itself, and we're off to the races. So if we just look at that again, and break this down a little bit, just to give it the same scenario. If we turn this into, so we got x equals 1, and then we have x minus 1. So again, it's canceling itself, and we end up with the 8. And if we just take that to, we just change the number and make this x equals 3. So we got x plus 6 and x plus 15 equals 162. And here again, x squared 5x, and there's 90 more. And that's what I'm looking at here. So this portion here represents the same idea. only just with a lot more squares. But it's just a little breakdown as to, we have it expressed in this way. When we break down the equation here, and we break down this whole area, we end up with two different representations. But here we have x minus 3, so it changes to 3, so this canceled out. So notice how this number gives us 8 times 3, but this adds up to 27, which tripled. So it's just a little, for instance, just a different way to look at quadratic equations and to break them down. And that's it.